G'day guys, we've got an applications of differentiation question today where it's asking us to find the tangent to the function y equals 2 on x plus x squared plus 16 on x squared at the point 2, 9. Now basically what the tangent is, it's a line that brushes the function once, and at the instant that the tangent touches the function, they share the same gradient. Now what does that look like on a diagram? Well, let's have a look. We've got a set of axes. Let's just make up our own little scenario here. We've got a set of axes, and let's get a function going. So we've got a function that looks like so: y equals f of x, and we're looking for the tangent at a particular point. Now, because the gradient of the function changes as x changes, what the tangent is going to look like is going to be dependent on where on the graph we decide to take the tangent from. So let's take it from here. So the tangent of this point is going to be a line that brushes the graph at that particular point, and at that particular point they share the same gradient. So what we've got here is our tangent is going to take the form y equals mx plus c. And the way that we're going to solve for this is we know that the tangent is at the point 2, 9. So if we've got this one here, we've got 2, 9. And we know that the gradient of this tangent line is going to be equal to, at this point here, the gradient of this function at that point there. So at this point here as well, we know that the gradient of the function is equal to the gradient of the tangent. Cool. So that's basically all we need to know to be able to solve this sort of question here. So let's get to it. We've got this function here. We'll write it down again. Y equals 2 over x plus x squared plus 16 on x squared. Now, to find the gradient of the function at x equals 2, y equals 9, we're going to have to take the derivative of this. So what I'm going to do, my sort of method when I'm dealing with our fractions where we have to, the x is in the bottom or the denominator, is I always bring the variable into the numerator. So I then will rewrite this function like this: 2 the x to the negative 1 plus x squared plus 16x to the negative 2. Now, this is a lot easier for me to differentiate than that is without making a mistake. Yes, it's a little bit more work, but it's easier to differentiate. So what I'm going to do now is I'm going to take the derivative of this, because that's what our gradient function is going to be. It's the derivative of y with respect to x of this function. So I'm going to have dy dx is going to be equal to negative 2 x to the negative 2 plus 2x minus 32 x to the negative 3. Now, I'm not going to explain the actual mechanics of differentiation. You guys should have that under control before you come to this video. There are many mechanics of differentiation videos on YouTube if you want to check that out. But here I'm just that's sort of assumed knowledge. So what I'm going to do here then is I'm going to divided by x squared plus 2x minus 32 on x to the power of 3. Now this x here is not that great. Let's get rid of that. That's better. Okay. Now, what we have to do to work out the first part of our tangent, is we have to work out the gradient. So this is what we're going to do first. So this value here, in the case of this question, is going to be equal to the derivative of our function dy dx evaluated when x is equal to 2. There. So let's do that. Change color. So I'm going to have dy dx evaluated when x equals 2. And that's going to be equal to negative 2 divided by 4 plus 2 times 2 is 4 minus 32 on 2, 4, 8. Now, we can simplify this. Negative 2 on 4 is negative 1 over 2 plus 4. 32 over 8 is then just minus 4. So this is then equal to just negative 1 over 2. So then we can write, therefore, m equals negative 1 over 2. Cool. So what we have to do now is we have to work out what our c is. So this is step 2 in working it out. So to work out c, what we then do is we substitute in our m value into the linear equation. And then what we do is we put in the fact that this tangent has to go through 2 and 9, and we just solve for c. Now I'll show you what I mean by that. Let's use this color. Hopefully it shows up. So we're going to have to start with y equals, we sub in m equals negative a half. So negative 1 over 2 x plus c. Now we know that this function has to go through 2, 9. So we know that y has to be equal to 9 when x is equal to 2, like that. We then multiply negative a half by 2, so we have 9 equals negative 1 plus c. So c, hopefully you understand that c would have to equal 10. So as you can see, what I've done is I've substituted in the coordinate point into my linear function and solved for c, because it's the remaining variable. Then all I do at the end is I'm going to write, so we're going to come all the way down to here, and then I'm just going to write, hence, the equation of the tangent is y equals negative 1 over 2 x plus 10. Cool. So you can see that it's a relatively straightforward question. There are a few nuances that you have to remember. You have to remember that at the point 2, 9, the gradient of the tangent and the gradient of the function are going to be equal to each other. So what we use that piece of information for is we used it to find the gradient of our tangent line. So we differentiate our actual function. We then sub in the point x equals 2 into our differential, and we work out what our derivative is evaluated when x equals 2. We found that was negative 1 over 2. There. Once we found that, we substituted that into the standard gradient intercept form of a linear equation, and we were left with y, x, and c as variables or unknowns. We then used the bit of information that the tangent has to go through this point, x equals 2, y equals 9. So we substituted that into our gradient intercept form of our linear equation, and all we had was c left. So once we'd done that, we could solve for c, and then as a result we have our answer, which is right here. So, it's not too complicated if you practice it enough, but, if you're seeing it for the first time in an exam, good luck, I guess. But, keep trying them. They're not too complicated. Just go practice, 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 practice. But I hope the video helped, guys. If it did, give it a like. You know, I'm just trying to build my channel, so all the likes I can get at the moment would be great. You know, subscribe also if you want to. I put out new maths videos and science videos all the time. Yeah, subscribe if you want. But until then, I'll see you guys next time.